Okay, hello everyone, welcome to you. And this is a video lecture series on basics of mechanical engineering for especially university exam preparation. And this is unit 3 in this I'm going to cover IC engine, and later on obviously I will cover automobile part. So this is lecture number 3 of this video series. So now I'm going to start with this IC engine. What is the working principle of four-stroke engine? So this lecture begins with four-stroke engine, four-stroke petrol engine and four-stroke diesel engine. Is it right? So here I am talking about four-stroke SI engine. SI engine means spark ignition engine. Is it right? SI means spark ignition. Spark ignition means for burning of or for combustion of fuel we need spark. Like when you start you can say gas stove. Then obviously when first you open the knob for LPG's gas, and then with the help of lighter you just ignite it. Then the combustion begins. Okay. So similarly, similar kind of thing is happen in the SI engine, in which when your air fuel mixture compressed, then you just provide a spark so that combustion takes place. Is it right? So you can see that this is a working principle of this four stroke engine, in which again you can say, if I talk about this okay, so now you can see this is nothing but from this is a filter actually, from where the air, or you can say this is a carburetor from where air fuel mixtures can enter. Is it right? So from this air fuel mixture is coming, and this is inlet manifold. Is it right? And of course this is a exhaust manifold. And if you have bike, then you can easily correlate this. Is it right? This is a silencer actually, from which this exhaust gas first move from silencer and then into the atmosphere, and its purpose is to collect all the harmful particles present in the exhaust gases, so that the clean air can move away from the this exhaust pipe. Okay. And of course here we have a valve. Then obviously this actually this mechanism is called inlet mechanism, in which we have carburetor and inlet valve. And this is inlet valve, this is inlet valve, this is exhaust valve. And you can say this is a spark plug you have seen in your bike. This is spark plug. Is it right? And you can say this is a cylinder. And this is a piston. And of course in the piston, if you see, if you have seen, then you can see in this piston we have a rings that is called piston ring. And this piston ring is basically flexible rings is provided at the top of the piston, so that it ensures the whatever combustible fuel we have inside the cylinder, it cannot move down. Is it right? And of course this is a connecting rod. This is a connecting rod. And of course this is a crank, and this is a crankshaft. And of course this is a crank casing. And this is a lubricant oil, lube oil, or you can say lubricant oil. Is that right? So these are the important parts, and then you can analyze how this four stroke engine works. Is that right? So let's begin. So you can see how the piston is reciprocating inside the engine, and this valve is open sometimes and this valve is open sometimes, and both valve can close. So you can say, okay, so when your piston is moving down at this position, is it right? At this position, in the next slide, I will explain you again. So when your piston is just positioned here, that is called top dead center, and at that location, you can see this valve get open, and when this valve get open, then whatever charge air fuel mixture we have, it enter into the cylinder, Is it right? Why? Because when your piston is moving down, then some vacuum pressure may arises, and because of less pressure, the air fuel mixture can enter into the cylinder. So this, when your piston is moving from TDC to BDC, at that time when the inlet valve is open and the charge may enter into the cylinder. So this is called as suction stroke. Is it right? So this process is called as suction stroke. So are you getting this? When your piston is moving from top dead center to bottom dead, from top dead center towards bottom dead center, then this inlet valve get open, and this exhaust valve get closed, and when it opens, then whatever fuel air mixture we have, then it enter into the cylinder. Is it right? So this process in which the air fuel mixture enter into the cylinder is called as suction stroke. Is it right? You can say this suction process is continuously happens. Yes or no? And now this is called compression stroke. When both valves get closed and your piston is moving from BDC to TDC, then whatever combustible fuel we have inside the cylinder, it get compressed. How it get compressed? Obviously, if large volume of air can uh, you can say, if you have a volume with a very large volume, then you have less pressure, and if similar air can filled in a small area or a small volume, then it get pressurized. And if it get pressurized means all the particles of the gases come closer to each other, then they exert more force. So then simply in the layman language we can say the pressure may increases. Is that right? So this is called compression stroke. When your piston after suction, when your piston is moving from BDC to TDC, then entire air get compressed because entire air fuel mixture is pushed in a small volume. So that's why compression takes place. And once the compression takes place, then you can say here both valve get closed and piston is positioned at the top dead center. Then with the help of this spark plug, when you provide spark, then combustion of the fuel air mixture takes place inside the cylinder. And while after combustion, since the pressure drastically increases, is that right? So because of that increased pressure, it pushes the piston down so that your piston can move from bottom dead center to top dead center. Is it right? From bottom dead center to top dead center. Is it right? So this is called power stroke. Is it right? This is called power stroke. And once again you can say this is power stroke, and again you can see here now, here this exhaust valve is open, inlet valve is closed, and now when your piston is moving again from BDC to TDC, then whatever combustible fuel we have inside it, then it move away from the exhaust manifold. Is it right? You can see now the entire process again. Correct? So you can see continuously these valves may operate it. It may open, it may close. Sometimes one inlet valve is open and both valve get closed. Sometimes exhaust valve is open and inlet valve is closed. So everything is happening here. Is that right? So from this you can analyze how your four stroke IC engine works. Okay. So now let's see for your exam point of view how to draw this figure. These strokes. So I am representing here. So everything is written here. So don't worry, I will provide this PDF. Everything is written here, but first I want to explain it. Okay. So simply you can say this, you just construct this. This is a cylinder. Is it right? This is a cylinder, and this is a piston. Initially your piston is positioned at the TDC. Okay. Initially your piston is positioned at TDC. Are you getting my point? And let's suppose if I take copy of this figure. Okay. So now you can see initially when your piston is positioned here at the TDC, is that right? At that condition, the inlet valve get open and exhaust valve get closed like this. Is it right? So when your piston is approaching from TDC to BDC, here we have BDC, is it right? So during this, the fresh air charge, air fuel mixture enter inside the cylinder. So this is called suction stroke. Is it right? Suction stroke. Are you getting my point? And now once the piston reaches at the bottom dead center, then suction process completed here. And after that, again, this piston is again approaching towards TDC from BDC to TDC. Is it right? And it is approaching along this direction. So obviously when you approach from, so this cylinder is completely filled with charge, and now when it is moving from BDC to TDC, so whatever charge we have here, and one more thing you can see, both valve get closed at this position, okay? Inlet valve and outlet valve, inlet valve closed and exhaust valve closed. Is it right? In short, I am writing here. This is exhaust valve closed, but here inlet valve is open. Okay, correct. So at that condition, when both valves get closed and your piston is approaching towards TDC from BDC, then the whatever charge we have inside cylinder, it is moving towards top surface, and hence its volume decreases, and along with this decreased volume, the pressure increases. So this process is called compression stroke. Are you getting this? This is called compression stroke. Is it right? This is called compression stroke, correct? Now after compression stroke, when your piston is situated somewhere here, again at the top dead center, then in this condition again both valve get closed, and with the help of this spark plug, you just provide a spark, then combustion inside the cylinder, combustion process takes place. Is it right? So again you can say this is inlet valve closed, exhaust valve closed, and your piston is approaching from TDC to BDC. Is it right? In this direction. So in this direction we will get power. So this is called power expansion. This is also called as expansion stroke. Why it is called expansion stroke? Because after combustion, here we consider the entire fuel can burn at a very instantaneous time. Is it right? So at a very instant, correct, means it does not require any time, but actually it is required time. But ideally we consider time is not required for burning of this fuel. So once you provide spark, then fuel can immediately burn. Is it right? So now in this condition, your pressure of these gases increases because of combustion, and hence these gases pushes the piston in the downward direction. Then piston can move from TDC to BDC, means this piston is approaching towards BDC from TDC. So this stroke is called expansion stroke, and in this expansion stroke is also named as power stroke, because this is the only stroke in which we will get a power. Is it right? And rest of the strokes we never get the power, we just provide the power externally. Is it right? So this is called expansion stroke, and once expansion stroke completed, means your piston is positioned at the BDC. Now again, now in this condition, your inlet valve get closed, again inlet valve get closed and outlet valve get open, and once outlet valve get open and your piston is again approaching from BDC to TDC, BDC to TDC, then because of this, since here the exhaust valve is open, and here we have combustible fuel, is that right? And your piston is approaching from BDC to TDC, then because of this open valve, exhaust open valve, these gases escape from the cylinder. Is it right? So this is called exhaust stroke. Are you getting my point? This is called as exhaust stroke. This is called as exhaust stroke. This is inlet valve closed and this is exhaust valve open. Is it right? So these are the four strokes which happen in the four stroke IC engine, four stroke SI engine. This is stroke 1, this is stroke 2, this is stroke 3, and this is stroke 4. Is it right? So these are the four strokes. And here if I write the full form of these terminologies, so this is inlet valve open. Is it right? And if I write IVC, then inlet valve closed. Is it right? And similarly, if I write EVO, then this is exhaust valve open. And if I write EVC, then this is exhaust valve closed. Is it right? So you just remember this. So these are the four stroke. This here I'm just writing full form of these terminologies: IVO, IVC, EVO, and EVC. Otherwise, here we have stroke 1, this is stroke 2, this is stroke 3, and this is stroke 4. So if in the question if they ask write down the working principle of four stroke engine, then simply you draw this figure and write down these strokes. Is it right? Then this is enough. And of course in the little bit you just explain what is the inlet stroke, then you simply write in the inlet stroke the inlet valve is open, exhaust valve is closed, and piston is approaching from TDC to BDC, then fuel air mixture enter into the cylinder. So this stroke is called as suction stroke. And similarly, when your piston is approaching from BDC to TDC, and in this condition inlet valve and exhaust valve both closed, then the air fuel mixtures get compressed. So this is called compression stroke. And similarly, you can explain expansion and exhaust stroke also. Is it right? So this is all about working principle of SI engine. So you can see here. And if I plot its PV diagram, that is pressure versus volume diagram, then it can be drawn like this. Obviously 0 to 1, this is called suction stroke. Is it right? 1 to 2, this is called compression stroke. 2 to 3, this is called you can say expansion. Sorry, this is not a stroke actually. In this you just provide a spark so that combustion of the fuel takes place. Is it right? Then 3 to 4, this is called expansion stroke, and 4 to 1 is called as, or you can say 5 to 0 is called as exhaust stroke. Is it right? So this is PV diagram. So you can see every detailed information is written here, which I already explained you. So I just provide this note, so you just read it, okay? Otherwise everything already I explained you, okay? And next you can see the compression ignition engine, that is called diesel engine. Is it right? Then obviously the diesel engine is developed by Rudolf Diesel at 1890, and it is very much similar engine to SI engine. The difference is in the diesel engine basically we use in this we use a diesel as a fuel, and this is a compression ignition engine. Is it right? This is a compression ignition engine. Why? Because diesel, if I talk about if we compare the petrol and diesel, then the boiling temperature of petrol is more than the diesel. Is it right? That's why petrol needs a spark, but the diesel has less boiling temperature, therefore only by the compression it can burn it, okay? So that's why this is called compression ignition engine. Is it right? That's why you can say this is called compression ignition engine. Simply in the petrol engine, its boiling point temperature is more. That's why fire external spark is required. And petrol in diesel engine, if I talk about diesel fuel, then its boiling temperature is less, then it can easily burn. So it can easily burn only by the compression, and here spark plug is not required. So that's why this is called compression ignition engine. Is it right? So rest of the difference I will tell you in the later on, okay? First let's see what is the working principle of compression ignition engine. Although the working principle is remains same as the SI engine, minor differences we have seen, okay? So let's see. So you can see here, this is a, again, this is a suction stroke in which the piston is positioned at the TDC. Yes or no? And the piston is approaching towards BDC. And in this, you can say this inlet valve is open, exhaust valve is closed. So this is called suction stroke. And of course, instead of a spark plug, this is a fuel injector. This is called fuel, not fuel injector. Actually, in the previous lecture, I think I told you that is fuel pump, but this is a fuel injector. This is not a fuel pump. Obviously, this fuel injector is connected with the fuel pump, but this is called fuel injector. So you can check it, okay? So this is a fuel injector, this is inlet valve, this is exhaust valve, piston, cylinder, crank, connecting rod, everything is remains same, just like a SI engine, okay? So once again, you can see when your piston is moving from TDC to BDC, then this is called suction. And this inlet valve is open, exhaust valve is closed. Now you can see both the inlet and exhaust valve get closed, and your piston is moving towards TDC from BDC to TDC. Is it right? From BDC to TDC. So this is called compression stroke. And during the compression, once at the end of this compression, when we provide fuel, when we provide fuel, and of course you can see here, we here only air can enter into the cylinder. Is that right? Only air. You just remember this, only air. While you can see in the SI engine, air fuel mixture enter into the cylinder, but here only air can enter into the cylinder. Are you getting my point? In the previous one you have seen only air, sorry, in the SI engine, air fuel mixture both can enter into the cylinder, but in case of diesel engine, or you can say compression ignition engine, only air can enter into the cylinder. Are you getting my point? During the suction stroke, is it right? During the suction stroke, only air can enter, okay? And at the end of this compression, at the end of compression, here we have compressed air, you just inject the fuel inside the cylinder instead of a spark. Is that right? In the previous one you have seen, at this situation we just provide a spark, but in compression ignition engine, since here we have compressed air, and now in the compressed air, when you inject the fuel, then automatically this fuel starts burning. Is that right? And after burning, obviously the pressure get increases, and hence your piston is approaching from TDC to BDC, towards BDC. Then this is called as expansion stroke, and this is also called as power stroke, because in this stroke we will get power. And once the piston can reaches at the BDC, after that again it starts moving up from BDC to TDC. Then in that condition, you can see here this exhaust valve is open now and inlet valve is closed. Then whatever combustible we have inside it, it is escaping from the cylinder. So now the process is completed, and the same process is repeated throughout the operation of the engine. Is it right? So again, you can see here we have suction stroke, compression stroke, expansion stroke, exhaust stroke, just like a SI engine. Is it right? And then what is the difference? The difference is in SI engine, instead of air, we enter air fuel mixture both. Yes or no? And in the SI engine, here we have fuel spark plug, but in the diesel engine we have fuel injector. Is it right? This is another difference. Is it right? And here you can see at the end of compression stroke, you just provide the fuel air, you just inject the fuel inside the compressed air, then combustion takes place. But in the SI engine, instead of fuel injection, sparking takes place. Yes or no? And rest everything is remain same. And now if you compare the auto and diesel cycle, this is a air standard cycle for diesel engine, and this is basically PV diagram. Then you can see 0 to 1, this is suction stroke, 1 to 2 compression stroke, and at the constant pressure you just provide a fuel. And from the 3 to 4, here we will get a expansion stroke, and then 4 to 0, or you can say 5 to 0, this will be called as a exhaust stroke. Okay, so let's see, everything is written here, you just read it. Okay, although I have explained you each and every detail. So let's see the difference between the diesel and petrol engine. So first here I am drawing SI engine. This is also called as petrol engine, SI engine or petrol engine. Are you getting my point? And on the basis of PV diagram, I am differentiating here. Is it right? On the basis of PV diagram, I am differentiating both SI and CI engine. Is it right? So you can see here, this is a basically SI engine, that is spark ignition engine. I am not writing again and again. And this is compression ignition, that is CI engine. Is it right? Of course, in the SI engine, we use petrol as a fuel, and in CI engine, we use diesel as a fuel. Is it right? So, in the petrol engine, if I draw the air standard cycle, then here we have this PV diagram. You can see here. Ideally, we draw only this, okay? So, this is 0, 1, this is 2, 3, 4. Is it right? And again, you can say 0, 1, 2, 3, 4. Yes or no? So you can see here, this 1 to 2, 0 to 1 is a suction, and here 0 to 1 is a suction. Okay, same. Then 1 to 2 is a compression. Yes, here we also have 1 to 2 is a compression. Okay. Then 2 to 3 is a uh, combustion. Okay, at constant pressure, constant volume, constant volume combustion. Yes or no? And here 2 to 3 is a constant pressure. Is it right? Here you can say this is actually a vertical line. Is it right? Exactly vertical line. Okay. So here volume V2 is V3. Both are same and this is constant. Okay. That's why this is called constant volume combustion. And this is constant pressure combustion. Here the pressure is remained same. This is a horizontal line. Okay. At this, here we have P2 is equal to P3. And this is constant. So constant pressure combustion. Is it right? So this is the main difference between SI and CI engine. You can see here we have constant volume and here we have constant pressure combustion, and rest everything is remain same. You can say 3 to 4 is expansion. Is it right? And here we have 3 to 4 is expansion. Is it right? And similarly 4 to 1 is a exhaust stroke, and here 4 to 1 is exhaust. Yes or no? So the only in air standard cycle, if we see the difference, then you can see in the SI engine we have petrol as a fuel, in CI engine we have diesel as a fuel, and obviously here the combustion of the fuel takes place at constant volume, and here the combustion of the fuel takes place at constant pressure. This is the major difference, and rest difference you can see in this slide. So on the basis of the basic cycle, then Otto cycle is a constant volume heat addition cycle, and this is called constant pressure heat addition cycle. Is it right? Heat addition means combustion of fuel. Okay. Next, fuel. If I talk about fuel, then we basically use gasoline, which is highly volatile fuel, diesel oil, which is non-volatile fuel. Is it right? Self ignition temperature, you can say it is self ignition temperature. This is the appropriate word actually, which I forgot. Self ignition temperature of the SI engine means a petrol. Self ignition temperature of petrol is high, and here self ignition temperature of diesel is comparatively low. That's why for burning of petrol we need a spark, and here for burning of diesel spark is not required. Okay, only compression is enough. If I talk about the introduction of fuel inside the cylinder, then obviously we use fuel air mixture. Is it right? And here only fuels, only air can compressed, and after that fuel get injected. Is it right? Load control, then obviously here we have throttle control. Is it right? Throttle control means by just accelerator you can uh, open and close the valve so that air fuel mixture supply increases. Okay, that's why this is called throttle control. But in case of CI engine, it is basically it is controlled by governor. Okay, and only quantity of fuel can regulate it to control the load. Is it right? Because air is same amount of air get compressed inside the cylinder, only amount, the quantity of fuel controls the power supply. Is it right? So when you need more power, then you just increases the fuel supply, and when power is required less, then less fuel gets supplied. Okay. Next, ignition, if I talk about, then obviously this is a spark ignition and this is a compression ignition. And compression ratio, you can see in a SI engine it will be low in the range of 6 to 10, but here the compression ratio will be very high, around 16 to 20. That's why diesel engine size will be bigger than the petrol engine size. Is that right? But here the compression ratio is more. Now if I talk about the speed, and one more thing, because of this compression ratio, the efficiency of the SI engine will be low, while the CI engine have more fuel economy, more efficiency. Is it right? That's why diesel vehicles gives more fuel economy than petrol vehicle. Okay. But in, if I talk about the speed, then of course SI engine is due to lightweight. It is also homogeneous combustion. It is provided high speed engine. Is it right? But since here the heterogeneous combustion takes heterogeneous, and what is homogeneous and heterogeneous? See, in a SI engine, both air fuel mix together in the carburetor and then enter into the cylinder. Though then we have uniform homogeneous mixture of air fuel. That's why here we will get homogeneous combustion. But in CI engine, only air get enter into the cylinder and it is compressed. After that, separate fuel is supplied. Therefore, homogeneous mixture of fuel air is not provided, not possible. That's why here we will get heterogeneous combustion. Is it right? And because of this heterogeneous combustion, then CI engine produces more sound, more vibration. Is it right? That's why this is suitable for low speed engine. Is it right? So you have seen in the bus or a truck, generally we use CI engine, and the car or in the bikes we generally prefer SI engine for light load and for high speed. CI engine heavy load, low speed. Is it right? And thermal efficiency, obviously here we have low thermal efficiency because of low compression ratio. It's sorry, here we have low compression ratio, so thermal efficiency, maximum value of thermal efficiency that can be obtained, it will be lower. Okay, so thermal efficiency because of low compression ratio. Why? You can see the formula for SI engine. If I write efficiency formula, then it will be written as 1 over RK to the power gamma minus 1. Is it right? 1 minus 1 by RK to the power gamma, where RK is a compression ratio. Is it right? Either gamma minus 1 over gamma. I actually forgot this relation, so you can check it. So because of this reciprocal relation, lower compression ratio leads to low thermal efficiency, while as a high compression ratio of CI engine leads to higher thermal efficiency. So this is all about difference between spark ignition engine and compression ignition engine. Is it right? So here in this lecture, actually I discussed what is SI engine, 4-stroke SI engine, 4-stroke CI engine, their working principle and their strokes, 4 strokes like a suction stroke, compression stroke, expansion stroke and exhaust stroke. Is it right? Their construction features, PV diagram and their difference between SI and CI engine. Is it right? So from this lecture, you can learn these things. Okay. So in the later on lecture, I will discuss 2-stroke engines, 2-stroke. Okay. And the difference between 2-stroke and 4-stroke engine. Okay. So one more lecture is required to complete this IC engine part for basic mechanical engineering point of view. Okay, and after that I will discuss automobile. Okay, so thanks. Now I'm going to end this session. Thank you and good day to all of you guys. We'll meet in the next lecture.